Hi, and welcome to Lesson 5, Fraction Exponents. This is the meaning of what a fractional exponent is. If you notice at the very bottom of your screen, there is an example. A to the 1 over n is equal to the nth root of a. When you're dealing with radicals, you don't have, there are limitations to what a radical can do. And so by changing a radical expression into fraction exponents, you have more power. And so the rule for fractional exponents for integers m and n with n is greater than 0, that means positive, and any non-negative real number a to the 1 over n is equal to the nth root of a. For example, a number written 4 to the 1/3 power really just means the cube root of 4. Notice the bottom number of the fraction is the index on that radical, and the power of 1, it becomes the exponent on that whole entire power. So let's practice changing fraction exponents back into radicals. Okay, first of all, we know that 9 to the 5/2 power means that the bottom number, the 2, becomes the index of the radical. The base number is the number inside the radical, and then the top number, that 5, becomes the power on the 9. Now you could write that power on the 9 on the inside of the radical, or you could also write that power on the outside. It means the same thing. So for part B, to change 4 to the 3/5 power into radical form, you're going to have an index of 5 and a power of 3 on the 4. And then working backwards, you've got the 5th root of 3 to the 9th power, and so the big number, the base, is 3. Then the numerator of that fraction is the exponent, and the denominator is the index of that root. And the same thing is the case when you deal with letters. Variables don't matter, it works the same way. And so we've got x to the 2/3 power. It really helps when you are trying to solve equations using exponentials if you know all of these common exponentials. And so at this point in the video, take a minute, push the pause button, and write down all these common exponentials into your notes. Notice that there is a color coding on some of them. For example, there are a couple of 16s and they are both green. I just want you to notice that sometimes common exponentials have the same value. Don't forget to push pause to write down all of these common exponentials. Knowing those exponentials really helps when you're trying to evaluate these expressions. And so we've got the expression 81 to the 1/2 power. Now we could change this back into radical form so that we know we're looking at the square root of 81. And of course you know the answer to the square root of 81. But a better way, or another way, to find the value of that exponential expression is to take the value of 81, go back to your chart, find 81 on the chart. Okay, 81 is 9 squared, all the way over here. And so replace 81 in this problem with 9 squared. So we're really looking at 9 squared to the 1/2 power. Now if you remember your rules for exponents, we're looking at a power raised to a power. And so in order to evaluate or simplify that expression, we need to multiply 2 times 1/2. Well, 2 times 1/2 is 1, so we're looking at 9 to the 1st power. And of course that matches what you knew the square root of 81 to be. So on number 4, we're looking at 64. Now on the chart, 64 is a color-coded number. 64 is actually listed 3 times. It's over here with 2 to the 6th. It is right here with 4 cubed. And all the way up at the top right column, you've got 8 squared is equal to 64. Now, here's how you know which one to choose. Look at the denominator of the fraction on this rational exponent. Happens to be a 3. In the chart, find the power of 3 that makes 64. And so we're going to choose 4 cubed. 4 cubed is equal to 64. That's the one we're going to put in place of 64. We're replacing 64 with 4 cubed. Then we're going to raise that to the 4/3 power. And so if you evaluate power to a power, 3 times 4/3 gives you 4. And so we're looking at 4 to the 4th power. And you can just leave it 4 to the 4th power. Occasionally I'll have you find the values of those exponentials, but 4 to the 4th is really big anyway. So let's just leave it 4 to the 4th. And then the next problem also has a 64. This time it's raised to the 5/6 power, and so we're looking at that denominator of 6, and that's going to be our 2 to the 6th power. That's the exponential we're going to use for this problem. 2 to the 6th power is equal to 64, so I'm going to replace 64 with 2 to the 6th power. And that is, of course, raised to the 5/6 power. And so 2 squared raised to the 5/6 power is 2 to the 5th. And that one's on the chart. We can evaluate that to be 32. So either one of those answers are fine. And then hopefully you recognize the 4 immediately as 2 squared. And 2 squared to the 3/2 power is 2 to the 3rd, which equals 8. Okay, let's keep going with some more examples. Let's look for 8 on the chart. 8 is listed, here, let me erase these 64s. We don't need those anymore. Okay, 8 is 2 cubed. Okay, so this is the power of the exponential we're looking for. Let's make sure that fits. It does, because there's a 3 in the denominator. So 2 cubed to the 5/3 power, when you multiply 3 times 5/3, you get 5. And 2 to the 5th is 32. 243, do you remember that one from the chart? Let's see if we can find it. Okay, let's see. I think it's going to be, wait, what was the number? 240. Oh, there it is, 3 to the 5th power. 3 to the 5th power is 243. So we'll replace 243 with 3 to the 5th power, raise that to the 2/5 power. Hopefully you're catching on at this point. When you multiply a whole number times a number with that whole number in the bottom, you just cancel those out. You get that numerator power. So 3 squared is equal to 9. 343. Let's see, 343 on the chart. If we click back to the chart, 343, I'm going to have to scroll, is 7 cubed. That's all the way down here. 7 cubed is 343. So let's replace 343 with 7 cubed. We're raising that to the 2/3 power. 3 times 2/3 is 2, so we're looking at 7 squared, which we can evaluate as 49. And then number 10 says 216. 216 on the chart is 6 cubed. And so we'll replace 216 with 6 cubed. We're raising that to the 4/3 power. So it's 6 to the 4th. And that's a pretty big number, so we'll just leave it at 6 to the 4th power.